So this is again a question given in JEE Advanced Chemistry Paper 1 2017. Okay, so where here they have given you a passage. Okay, so this is a column. Basically, this is a passage based question which has 3 parts. Okay, and this is one column given in the question paper. Okay, this column has 3 sections. So this was your column 1. This was your column 2 and this was your column 3. So this is a quantum chemistry based question, okay, and 3 questions were asked on the basis of this column, question 1, question 2 and question 3, okay. So let us try to solve each questions based on the column given, okay. So I hope you know the values like psi is the wave function and z is the atomic number, and you can give any orbital in this form in quantum chemistry, okay. So I am not going to get into the theory. Now let us see what is the information given and what is asked in the question. So first question is for H atoms correct combination is asked, okay, and everything is theoretical except this. You need to calculate the energy. N is equal to 2 to 4 is 27 by 32 times of N is equal to 2 to 6. Okay. So let us try to solve. Okay. I don't have much space, so let us try to solve here. So energy, you know, it is 1 by N1 square minus 1 by N2 square. Okay. So if I want to calculate energy, N1 is my 2, so it is going to be 4 minus N2 square is going to be 16. Okay, and divided by I need the ratio, right? So N is equal to 2 to 6. So that means 1 by 4 to 1 by 6, that is 36. So this is going to be 4 minus 1, that is 3, and it is going to be 6 minus 4. So this is going to be essentially 16, 3 by 16 divided by 36, okay, 9 minus 1. So this is going to be 8. So I can write this as 4, right? So 9 3 are 27, 8 4 are 32. So answer is 27 by 32. So this option is correct, okay? So this option is correct. Fine. So from this calculation, what I know, this option is correct. How I did this calculation? Because energy is, see, if you are say exciting electron from N1 to N2 energy level, we know that energy is directly proportional to 1 by N1 square minus 1 by N2 square. So my 2 to 4 transition energy is going to be 1 by 4 minus 1 by 16, right? 1 by 4 minus 1 by 16, because 1 by 2 square minus 1 by 4 square, and for the other transition that is given is N equal to 2 to 6. So that means 1 by 4 minus 1 by 36. So if we solve this, we are going to get 37 by 27 by 32. So this option seems to be correct. So now let us move to the questions and see what is there. So for hydrogen atom, correct combination is there. So correct combination I need, in first column it is given 2, that is 2s orbital, that is going to be incorrect, okay, because we are talking about hydrogen atom, we are going to deal with the 1s orbital first, okay. So 1s orbital, this option has 1 as 1s orbital, 4, it says that xy plane is the nodal plane. 1s orbital, for 1s orbital, the xy plane cannot be a nodal plane, okay. So this option is again incorrect, this option is again incorrect. If we go to option C, it says 1, that is 1s orbital, then 1, this is the wave function of 1s orbital, okay. If you know this is the wave function of 1s orbitals, then 1 it is correct, match 1 it is correct. For S, it is already correct, okay, we have already calculated. So option C is correct. If you move to option D, that is 1, that is 1s orbital, 1 that is wave function of 1s orbital, it is correct, and after this it is given P, that is this, okay, and that is incorrect, right? For 1s orbital, this cannot be the plot, because it is showing that you have a nodal plane here, okay. Whenever it is crossing this axis, psi is crossing 0, that means you have a nodal plane, and you don't have a nodal plane in 1s orbital. So this option is again incorrect. So what is going to be the correct option? 1 1s, okay. Let us move to the next question, where it says that for helium incorrect combination they have asked, okay, incorrect combination. So option number A, it has 1, okay, 1 is matched with 3. If you are taking the 1s orbital of helium, it is matched with 3. So 3, it cannot be the wave function of 1s orbital. It has cos theta, it comes when you deal with the higher like p orbital and all, okay, and 5 by 2 cannot be for 1s orbital, right? It is 3 by 2. So this option is incorrect. So this option is incorrect here. Here this option is incorrect because they have asked incorrect options. Let us go to the B, which says 2s orbital, 1 radial node. That is correct. In 2s orbital we have 1 node, okay, you can say, and Q, probability density is at the nucleus. So this is going to be correct, okay, because in S kind of orbitals what we have seen, probability density is there at the nucleus, okay. 1 1 S is correct. We have already seen 1 1 because for 1s orbital this is the wave function and S is already correct. So this is going to be correct. 1 1 R. So 1 1 and R. A maximum probability at the nucleus. For 1s orbital, maximum probability is at the nucleus, right? So this is going to be correct. So only incorrect option that we have is A. Okay. Now let us move to the third question, which says that correct combination for any hydrogen-like species. Okay, any hydrogen-like species. If we go for first option, it is given that 4 4 and R. Okay. So 4 means you are taking 3z square orbital. 4 xy is the nodal plane, but we know that dz square orbital doesn't have a nodal plane in xy plane. So there is an electron density, there is a ring around dz square orbital, right? It looks like this. So there is a ring around xy plane, so it cannot be the correct option. So it is incorrect. Okay, let's go to the option B, which says 3 3 and P. Okay, so 3 is 2pz, this 2pz is correct, and then we have P. But this is not for 2pz orbital, this is for 2s orbital, right? So it is going to be incorrect. We have, because if you plot for 2pz, you are not going to get a radial node there, okay? So if we go to option C has 2, 2 and P. So 2 is 2s orbital, it has 1 radial node, it is the plot of 2s orbital, okay? So it is going to be the correct option, okay? If we go to option D, we have 1, 2 and S. So 1 is 1s orbital, 2 is 1 radial node, okay. 2s or 1s orbital doesn't have a 1 radial node, right? So we can just cross this as well. So now we know the correct answers for each of the questions. So here option number C is correct, where 1s has a wave function and it has a energy, the ratio of energy from 2 to 4 to 2 to 6 is 27 by 32. Here 1, 3 and R, 1 is this 1s orbital, 3 is incorrect because this is not the wave function of 1s orbital, R is anyway correct, okay. So here they have asked incorrect option, so that's why this is going to be the answer. Here correct combination for C 2 2 P, so 2 is 2s orbital, this has 1 radial node and this is a plot of 2s orbital, okay. So this is the correct option. Option number C.